Hello class. Today we're going to look at solving simple linear equations. We're going to start out with some basic ones where all we're doing is adding or subtracting and dividing. And then we'll move on to more complicated things like multiplying, working with parentheses, maybe even some exponents. We'll see. Alright, we have some basic rules when we're solving for each variable. The first being, the main rule being, the main idea, I should say, being, we want to get whatever variable we have by itself. Okay? Whatever variable we have, we want to get it by itself. Now, think of the equal sign as what's splitting your equation. Okay? Now, in order to cross the equal sign with a number, you have to do the opposite of what that number is initially doing. Okay? So, in order to get z by itself in this first equation, where we have 3z plus 4 equals 34, we need to get rid of that plus 4, and we need to get rid of that 3 that is multiplied to that z. Now, the first thing we look at doing is almost the opposite of PEMDAS here. The first thing we look at doing is actually your addition or subtraction. Then we look at if we can multiply and divide anything across. Okay? With PEMDAS, you would do your parentheses, exponents, multiplication, division, addition, subtraction. Here we're kind of working backwards. We're doing addition, subtraction, then we're doing multiplication, division. So, I want to look at what's added and subtracted first and move those constants first. Okay? Here I have a plus 4 on this side. So I want to move it to the other side of the equal sign to help get z by itself. In order to do that, I need to do the opposite of what plus 4 is. The opposite of plus 4 is minus 4. So I need to subtract 4 from both sides. Okay? This simplifies to 3z equals, now 34 minus 4 is 30. Okay? So now we almost have z by itself. We only have to worry about that one more thing, that 3 that's multiplied to it. Now remember, in order to cross this equal sign, I have to do the opposite. Okay, so if I want to get rid of that 3, I have to do the opposite of what is being done to that 3 right now. Right now that 3 is multiplying times z. The opposite of that is division. So I'm going to divide each side by 3. That cancels the 3's out here and leaves me with just a z. And then 30 divided by 3 is 10. So my final answer here is z equals 10. Let's move on. Number 2 is 2u plus 10 equals 22. Now, I'm going to do and get rid of the additions and subtractions first. Kind of work backwards from PEMDAS when solving. Okay, I'm going to do a minus 10 because in the equation above, 10's added. I want to do the opposite so that it will cancel itself out. 10 minus 10 is obviously 0, so it cancels itself out. 22 minus 10 is 12. And remember, you still have the 2u up here. So some of you may have seen it like this. Up here, I just dropped the 4 off on number 1 because 4 minus 4 is 0, so I dropped it off, but maybe you didn't see the step that I was actually doing there, so I'll reiterate the small step that was done here. Here is 2u plus 0 equals 12, which is the same thing as 2u equals 12 because 0 plus anything is 0. Okay. Now we want to get this u by itself, so the only thing that's bothering the u right now is that 2. Okay, it's 2 times u. I need to do the opposite, so I'm going to divide each side by 2. That cancels these 2's out. Okay, and 12 divided by 2 is 6, so u here equals 6, and that is our answer. Okay, so try to move the additions and subtractions first, then look at your multiplication and divisions and try to cancel those out next. Let's go on to number 3. 2y plus 1 equals 17. I'm going to work with that addition and subtraction first. So here I have a plus 1. To get rid of it, I'm going to subtract 1 from both sides. Okay, 1 minus 1 is obviously 0. 17 minus 1 Okay, this gives me 2y plus 0 equals 6, which is the same thing as 2y equals 16. Okay, I may have spoke wrong in that intermediate step there. I said 2y plus 0 equals 16, which simplifies down to 2y equals 16. And then I need to get rid of this 2. Okay, this 2 is multiplying times y, so I need to do the opposite in order for it to cancel out. I need to divide. So when I divide here, it cancels itself out. I'm left with y equals 16 over 2. We know that 16 divided by 2 is 8. So my final answer is y equals 8. Okay, I think we're getting the hang of it. Let's look at number 4. Number 4 says 3c plus 8 equals 14. I'm going to subtract 8 to start with. This is going to give me 3c equals 14 minus 8. Now 14 minus 8 should give you 6. Okay. Obviously these 8's cancel themselves out. Positive 8 and negative 8 cancel themselves out. This gives us the 6. I need to get c by itself. I divide by 3. And I get c equals 2. Okay. You know how I do. I usually do the first column. Try to take it nice and easy. But I speed up slowly but surely, because we need to get at a college speed here. Okay. Alright. I have 2c plus 7 equals 17. So I'm going to subtract 7 from both sides. That's going to cancel these 7's out. Okay, it's going to zero that out. 17 minus 7 is 10. I've got 2c equals 10. I'm going to divide by 2. And here, c equals 5. Okay. Not too bad. Not too bad. All right, I'm going to scroll back up and start on number 6. Okay. So let's start on number 6. 3x plus 2 equals 5. Okay. I'm going to subtract 2 over. Cancels that 2 out there. Gives me a 3 here. So I have 3x equals 3. I'm going to divide each side by 3. Those 3's cancel out. I have x equals 3. I highly encourage you to pause the video, work the problem by yourself, and see if you're getting the same answers that I'm getting. Okay. This is for your practice. I'm here to show you the steps in case you mess it up, but you need to be practicing on your own as well. So be sure to take advantage of that pause button. Number 7 says 2a plus 14, or plus 4 equals 14. 2a plus 4 equals 14. I'm going to subtract 4 from both sides. It's going to give me 2a equals 10. I'm going to divide by 2. This is going to give me a equals 5. Okay. All right. Picking up speed here a little bit. I've got 2c plus 6 equals 18. I'm going to subtract 6. I'm going to get 2c equals 12. I'm going to divide by 2. I'm going to get that c equals 6. Number 9, 2x plus 8 equals 22. I'm going to subtract 8. I'm going to get 2x equals, let's see, 22 minus 8. That should give us 14. So I'm going to divide by 2. And here x equals 7. See the importance of knowing your basic addition and subtractions. Your basic addition and subtractions for small numbers, and especially your basic addition or multiplication and division for smaller numbers. Gotta know those. Be on point with those as best you can. All right, number 10 says 2u plus 4 equals 10. So I'm going to subtract 4 from both sides. I'm going to get that 2u equals 6. I'm going to divide by 2 so that u equals 3. All right, last row of this worksheet, and then we'll move on to something a little harder. Okay, like I said, take advantage of the pause. Take advantage of the pause. I want to see you work it and get the same thing that I do. And then once you've done a few of these, so we're on number 11, so see how fast you can do them. Okay, now obviously don't want to go so fast you make a mistake, but challenge yourself to pick up speed with these. Okay, because we need to be really fluent. The quicker you can do stuff and do it correctly, okay, keep that in mind. Do it correctly. If you're doing it fast and wrong, that's bad. But we want to do it fast and correctly. Okay, so start out slow. Make sure you're getting it correct. It's kind of like any sport that you're practicing for, right? Okay, you're doing an event. You're practicing that event. You're starting out slow, going through the motions, making sure you get your form down. As you get better, you're picking it up. You're speeding up. This is exactly the same thing we're doing here, just more practice. I got 3z plus 5 equals 8. I'm subtracting 5. I'm getting 3z equals 3. I'm dividing by 3 so that z equals 1. Okay. Number 12. I've got 2c plus 4 equals 22. I'm subtracting 4. I've got 2c equals 18. I'm dividing by 2 so that c equals 9. That's how fast I want to see you do it when you get in my class in college. Alright, I got 2x plus 5 equals 23. I want to subtract 5. 23 minus 5 is 18. I've got 2x equals 18, so I have x equals 9. Okay, I've got 2v plus 3 equals 23. I'm subtracting 3. I've got 2v equals 20. I'm dividing by 2 so that v equals 10. Okay. Last but not least, number 15, I have 2c plus 7 equals 21. I'm subtracting 7. I've got 2c equals 14. I'm dividing by 2 so that c equals 7. Okay. Alright, that worksheet's done. That worksheet's done. Like I said, obviously don't expect you to be quite as fast as I was right there at the end. Ideally, that would be perfect. If you were that quick and could work through that math that fast, you're going to be on a really, really good pace coming into this first couple classes you have here at the university. But not everything's going to be that simple, obviously. So, let's continue on and look at something a little more complex. Alright, here I have 8 times 4a minus 4, close parentheses, minus 1 equals 14 minus 8a. Okay, so it's going to get harder. This is exactly what we've done. Now, we are solving these equations. But in order to solve these equations, we also need to simplify at the same time. Okay, so what I like to do, if it's possible to simplify, I do that first. Okay, if it's possible to simplify, I try to do that first. So in this first equation here, I'm going to simplify the left-hand side of the equation. The right-hand side of the equation is as simple as it can be for the time being. But the left-hand side of the equation can be simplified. The first thing I'm going to do is distribute this 8 into the parentheses. Okay, 8 times 4a is going to give us 32a, and 8 times negative 4 is going to give us negative 32. I still have to account for that 1, or that minus 1, and I have to account for the other side of the equation as well, so I'll rewrite that. I have another step that I need to go to simplify this left-hand side of the equation. So I have 32a. Okay, the minus 32 and the minus 1 we can combine together to get a minus 33. Okay, and that equals 14 minus 8a. Alright, now we have a's on both sides of the equation. A is our variable. You can do this several different ways and get the correct answer. The method that I use is I always try to move the smaller variable. Okay, I try to move the smaller variable to the bigger variable. Okay, that's my main method. I try to move the smaller variable to the bigger variable, and then I try to move everything else to the other side. So I'm going to move the smaller variable to the bigger variable. So here I have a 32a on one side and a negative 8a on the other side. I'm going to move the negative 8a over to the left-hand side and combine it with that 32a first. And then I'm going to move my constant, that negative 33, over here to that positive 14 so that I have all my a's on one side and all my constants on the other. Let's do it step by step. So first thing I'm going to do, I'm going to add 8a to both sides because we still have to do the opposite of what's being done. Okay? Alright, so 32a plus 8a is going to give us 40a, and we still have the minus 33 equals 14. Now, I'm going to add 33 to the other side. Okay? That cancels it out over here. And now 14 plus 33 is going to give us 47. Okay? Alright, so my equation is now 40a equals 47. Okay, I still need to get a by itself, so I'm going to divide by 40, and I get that a equals 47 over 40. Okay, if I can reduce that, I would reduce it. At this point, it can't be reduced. I'm just going to leave it as that fraction. Okay, so strategy here. Strategy. I am moving my smaller variable to my bigger variable, and then I'm moving everything else to the other side and getting that variable by itself. Okay, started out with a simplification, simplify, move the smaller variable over to the bigger variable, move everything else to the other side, and then try to cancel everything out of that a. Okay, all right, let's try number 2. Try number 2. I've got 4 times parentheses negative 8x plus 5 equals negative 30x minus 26. I need to simplify this left-hand side first. I'm going to start by distributing it in order to do that. So here I have 4 times negative 8 is negative 32x. 4 times 5 is 20. I'm going to rewrite my right-hand side of the equation. Okay. Now, I'm sticking with the same rules. Okay. Sticking with the same rules here. I'm moving my smaller variable. Okay. My smaller variable is technically the negative 32x. Okay. Okay. That's our smaller one there. Okay. It's a more negative number, so I'm moving it. So I'm going to add 32x to the other side. Okay. That's going to cause this to cancel. And then I'm going to have 20 equals 2x minus 26. Okay. See how that made that nice when I moved that? If I would have moved the negative 30x to the left-hand side instead, I would have wound up with a negative 2x, which is fine. We can solve it that way. It's not a problem. But this way, I have a positive number out in front of the x so that when I go to divide, I'm dividing by a positive number. When we have an equal sign, it really doesn't play much into it. But when you have inequalities, and you start dividing by negatives to solve equations with inequalities, it causes the sign to switch and flip, which can be a little confusing sometimes. So this kind of saves you there. All right, I still need to solve for x. So I'm going to add 26 to the other side. 20 plus 26 is going to give me 46. So 46 equals 2x. I'm then going to divide by 2 to get x by itself, so that I have x equals 23. And that is our answer for number 2. A lot more steps here. A lot more complicated than I dropped my mic. But still very manageable. Very manageable. Alright, let's try number 3. Number 3. Okay, I think there's 8 questions total on this one. So the first 4, I'm going to go step by step, real simple, quick, and easy. And then I'm going to speed up a little bit and see if we can hang on. Alright, number 3 says 27 equals 46 plus 3x minus x. Obviously can't simplify that left-hand side, but I can simplify that right-hand side before I go and start making changes here. Okay, so I have 27 equals 46. Now I have a plus 3x minus x, which should simplify down to a 2x. I still want to get this x by itself, so I'm subtracting 46 from both sides. Okay, obviously cancels itself out here. This should give us, let's see, what does this give us here? So that gives us, it's a little bit harder one, isn't it? I'm trying to do it mentally. It gives us 19, a negative 19. Okay, equals 2x. Then we can divide by 2. We get x equals negative 19 over 2. Now, depending on the class that you're in, they might want you to keep it as a fraction. They might want you to give it as a decimal. Here I'm going to keep it as a fraction. Okay? A lot of times we keep it as a fraction. But if they ask you to switch it to decimal form, obviously just do the division and switch it to decimal form. Not a big deal. Number 4, I have 38 plus 7k equals 8 times k plus 4. Okay. Now, I'm going to distribute this 8 to both terms over here, so I can simplify this down a bit before we start to solve. 8 times k is 8k. 8 times 4 is 32. Okay. Now, I'm going to move my smaller variable. In this case, it is the 7k. So I'm going to do the opposite of adding 7k, and I'm going to subtract it so it cancels itself out. This gives us 38 equals, now 8k minus 7k is just k plus 32. Okay. Then all I have to do is subtract 32 from both sides. Now 38 minus 32 should give us a 6, and that is what k is equal to. Okay, because these two 32's cancel themselves out. Now, the benefit of moving the smaller k here, it actually saved us a step. Because if we'd have moved the larger k, if we'd have moved the 8k, we would have had negative k equals negative 6. We would have had to do an additional division step to get rid of that negative. Alright, number 5. We have 2 distributions we need to do and a little bit of simplification. Let's look at it. It says negative 2 times parentheses 4 minus x, close parentheses, equals 6 times parentheses x plus 4, close parentheses, plus 4x. I'm going to start by distributing the negative 2 to both of these terms. Then I'm going to distribute the 6 to these terms on the other side. So I have negative 2 times 4 is negative 8. Negative 2 times negative x is positive 2x. 6 times x is 6x. 6 times 4 is 24. And then we still have to write that plus 4x on the outside. Now the left-hand side is as simple as we can make it for the time being. But the right-hand side, we can combine this 6x and this 4x to give us a 10x plus 24. Now, we're going to move the smaller x. So here I'm going to move the 2x. So it's plus 2x, so I'm going to subtract 2x from both sides. That's going to give me negative 8 equals 10x minus 2x is 8x plus 24. I want to get x by itself, so I'm subtracting 24 from both sides. Negative 8 minus 24 should give us, I believe, negative 32. So we have negative 32 equals 8x. Then to get x by itself, we divide by 8, and we get negative 4 equals x. Okay, we're good to go. Like I said, I keep saying it, I'm going to keep reiterating it. Please pause, try to solve these on your own, go back, watch how I do it. You might do it a different way and get the same answer. It's fine, as long as you're getting to the same final answer. There are several methods of solving you can use here, but make sure you're getting the right answer. Make sure you're following logical steps. Alright, number 6. I have 0.05z plus 0.2 equals 0.15z minus 10.5. Okay. I'm going to move the smaller z, the 0.05z, so it was added on the left-hand side, so I'm going to subtract it to cancel it out. And what I'm going to do is do it to both sides. Cancels it over here. And this leaves us with a 0.2 equals, now 0.15z minus 0.05z gives us 0.10z minus 10.5. Okay. Still have to get the z by itself. So I'm going to add 10.5 to both sides. Okay. This is going to give us 10.7 equals 0.10z. I'm going to divide both sides by 0.10. Okay. Now 10.7 divided by 0.10 should give us 107. Alright, technically all we're doing is moving the decimal place one place. But if you have a hard time with dividing and multiplying by decimals, just use a basic calculator. Okay. Most classes are going to allow you to use a very basic calculator at the least. A lot of the ones at our university allow you to use a TI-84, which can definitely do this decimal division no problem. Okay. So if you didn't see that all you really had to do is move the decimal place one place to make it 100 or make it 107 with that division, then use your calculator to help you solve that out. Alright, number 7. I have 4 times 6 plus 4x, which was in parentheses, equals 0. First thing I'm going to do, okay, I'm going to solve this one two ways. Okay, I'm going to follow the method to show you how we can make it a little simpler because it's equal to 0. Okay. So following the method that we've been doing, we would distribute the 4 to both sides to simplify the left-hand side of the equation. So 4 times 6 is 24. 4 times 4 is 16. So I have 16x, and that equals 0. I'm going to get the x by itself by subtracting 24 from both sides. So I'll have 16x equals negative 24. And then I'm going to divide both sides by 16 so that I have x equals negative 24 over 16. Now, 4 goes into both of these. Technically, 8 goes into both of these. So if I simplify this by a factor of 8, it gives me negative 3 over 2 as my final answer. Okay. Now, that's perfectly fine. That's a perfectly valid way to do it. But in mathematics, the more you learn about mathematics, the more you can learn some shortcuts and some secrets and stuff that kind of help you work through some methods to work through problems in different ways that are still valid. So, if I had to solve this problem, I wouldn't have solved it that way. What I would have done, I'm going to erase it all. It's perfectly valid how I did it. We got a perfectly correct answer, and I'm going to get the same answer solving it in this other way. But I just want to show you this other way. See what you think. Okay. All right. Now, if you notice, it's equal to 0 over here on the right-hand side. Okay. Because it's equal to 0 is the only reason I can do this. Okay. To make it simpler at this point. Because it's equal to 0, I'm going to divide by 4 to start with. 0 divided by 4 is 0. So I have 6 plus 4x equals 0. Okay, these 4's canceled out. 0 divided by 4, anything divided into 4 is 0. Okay, then I can just solve for x by subtracting 6 from both sides. I have 4x equals negative 6. If I divide by 4, I have x equals negative 6 fourths. If I reduce by a factor of 2, that reduces down to x equals negative 3 halves. So because this one was equal to 0, I could have started out with a division step instead of a simplification step. Okay, but only because it was equal to 0. Alright, number 8. Okay, number 8. Now with number 8, here's what we have. We have x divided by 8 minus x divided by 9 equals 1. Okay. Now, there's a couple ways you can do this. The best way to do it, in my opinion, is to find the LCM. Okay, the least common multiple. Hopefully you know what the least common multiple is. Now, the least common multiple here of 8 and 9 is actually what their initial multiple is, 8 times 9, which is 72. Sometimes it's smaller than that, but in this case, the least common multiple of 8 and 9 is 72. So if I were to multiply the entire equation by 72, then I could cancel both of these denominators out. Okay. What this means is I'm basically applying 72 to every part of the equation. So this technically gives me 72x over 8 minus 72x over 9 equals 72. Okay. 72 divided by 8 is 9. 72 divided by 9 is 8. And obviously we have the 72 still over there. 9x minus 8x is x. So we have x equals 72. That's how I would have solved it. There are other ways of solving it. Okay? You could have found a common denominator here. The common denominator would have been 72. Then you could have done the multiplication across the top. Then you would have had to do multiplication of the 72 over to the right hand side to that one after you combine those two fractions, which would have been fine too. But this is the method that I would do. Least common multiple, multiply the whole thing by the least common multiple, cancel out all your fractions, and then just go ahead and solve for your x. Like I said, other methods aren't wrong. So don't feel like you have to change your method. If your method works and is valid, stick with it. You're good to go. Okay. If you have any questions, reach out, let me know. Other than that, I will see y'all next lecture.